The paper of the day is CStore, a column-oriented database. This paper presents the design of a read-optimized relational DBMS that contrasts sharply with the most current systems, which are write-optimized. Among the many differences in its design are storage of data by column rather than by row, careful coding and packing of objects into storage including main memory, during query processing, storing an overlapping collection of column-oriented projections rather than the current fare of tables and indexes, a non-traditional implementation of transactions which includes high availability and snapshot isolation for read-only transactions, and the extensive use of bitmap indexes to complement B-tree structures. Paper presents preliminary performance data on a subset of TPC-H and show that the systems that they are building CStore is substantially faster than the popular commercial products, hence the architecture looks very encouraging. CStore is organized into two major systems, a writable store for handling update transactions and a read-optimized store for handling ad hoc queries. A tuple mover sits between these two systems and copies data from the writable store to the readable store as necessary. The writable store acts much like a traditional row-oriented database and handles insert and updates requests. The read-optimized store is a much larger component organized by column instead of rows. To provide data consistency guarantees, read-only queries are done on historical data using snapshot isolation. In the read-optimized store, data is split into groups of columns sorted on the same attribute called projections. The same column may exist in multiple projections, possibly in a different sort order. By offering different sorted orders of the data, reads can be optimized to process the most performant sort order. Every table is thus reduced to a covering set of projections that include every column of the table. To join projections together when running a query, storage keys are used to record the logical row of each attribute being stored along with the join index, mapping the segment ID and storage key of two tuples that can be joined together to form an original table. Data in the read-optimized store is compressed using existing compression techniques such as run-length encoding depending on the type of data being stored. The writable store is organized as a traditional row-oriented RDBMS. In addition to storing each record, the writable store includes the same storage key as the read-optimized store. Snapshot isolation. To avoid locking and two-phase commit for all reads, snapshot isolation over the read-optimized store is used for read-only queries. With snapshot isolation, read-only queries access the database at some time in the recent past where we can guarantee there are no uncommitted transactions. To determine if a record is visible without requiring a large amount of space, coarse-grained epochs spanning several seconds are used as the unit of time in CStore. Each segment in the writable store maintains an insertion vector which records the epoch in which the record was inserted. The tuple mover is responsible for ensuring that the correct updates and insertions are moved to the read-optimized store for proper epochs. Here are the key contributions of this paper. A hybrid architecture with a write store component optimized for frequent insert and update and a read store component optimized for query performance. Redundant storage of elements of a table in several overlapping projections in different orders so that a query can be solved using the most advantageous projection. Heavily compressed columns using one of several coding schemes, a column-oriented optimizer and executor with different primitives than in a row-oriented system. Highly available and improved performance through case safety using a sufficient number of overlapping projections, the use of snapshot isolation to avoid two-phase commit and locking for queries.